Bright Tuty. Every student matters.
Hello students, so let's continue the chapter mensuration. So the topic for today is area of a polygon. How do we find out the area of a polygon? So as you can see here, pentagons are drawn, right? It has 1, 2, 3, 4, 5 sides. The second one also 1, 2, 3, 4, 5 sides it has. Now in one of the figure, if you see, it has been divided into different triangles by joining the diagonals. So the diagonal AC and AD, these are made, and this pentagon then is divided into 1, 2 and 3 triangles as seen. Here the pentagon is divided into this triangle, that is the first part, this triangle second part, this trapezium as the third part, because if you see this side and this side, they are parallel and it's a trapezium. Only one pair of side is parallel. Now this is the fourth part. So in this figure, the pentagon is divided into how many? 4 parts. In the first one, it is divided into 3 parts. So like this, we can divide pentagons, hexagon, whatever polygon we have, into triangles, trapeziums, and then we can find out the area. Okay, so this is how we are going to find out area of any polygon. Okay, so if you see here, there is a question given. They're asking you to divide the following polygons. They're asking you to divide the following polygons into parts, that means into triangles and trapeziums. So we have to divide both of them into triangles and trapeziums to find out its area. Okay, now in the first one, they are saying Fi is the diagonal of EFGHI. So we see that EFGHI, this is a pentagon, right? This is a polygon given to us. And here NQ is the diagonal for this one, MNOPQR. Right, this hexagon is given having 6 sides, 1, 2, 3, 4, 5, 6. Okay, so 6 sides we have. So like this, we have been given 2 figures. We have to convert them, or we have to divide them into parts of triangles and trapeziums. So just see, if you draw a perpendicular from here and you draw a perpendicular from here on this diagonal, so this and this, just to see, they are opposite and they're parallel. So this is a trapezium, this is a triangle, this is a triangle. EFI is also a triangle. We can drop out height like this, right? In this also, from O we can drop out a perpendicular, from P we can drop a perpendicular. So this is a trapezium, and 1, 2, these are what? These are 2 triangles. Also we can join N to R and we can get 2 triangles, right? Or if we do not join this diagonal, what we can do is, we can draw perpendiculars like in the upper part. So from M you can draw, from R you can draw. So this will become a trapezium, and this, that means, suppose I name it as P dash and Q dash. So we have NP dash M as one triangle, R Q dash Q as another triangle, right? So there are 4 triangles and 2 trapeziums that are made in it. So this is how we can divide the polygon given into triangles and trapeziums, by dropping out perpendiculars. Okay, now we are going to do some questions through which the concept would be more clear to us. So let us go ahead. Here if you see, they're saying polygon ABCDE is divided into parts as shown in the figure. As you can see, it is divided into triangles and trapeziums. We have to find its area. If measurement of AD, complete AD is given as 8 centimeter. Okay, so this AD is 8 centimeter, the complete one. Then AH is 6 centimeter. This one from A to H, this much is 6 centimeter. And then we are given AG. So if, just to see before that, if AD is 8, AH is 6, what about this? This is 2 centimeter, right? DH is 2 centimeter. AG is given as 4 centimeter. Okay, AG is how much? 4. That means from here to here, this is 4. Then what about this GH? This will be 2, because the total is 6. Okay, then we have AF as 3. This is 3, right? And AH is already given to us, that is 3 here. Now perpendiculars BF is 2 centimeter, and the another one, that is CH, it is 3 centimeter, and then we have EG, that is 2.5 centimeter. Right, we have been given the measurement of all. Now they are asking area of polygon ABCD is area of triangle AFB plus what we need to write, area of triangle this AFB they have written, then what we are going to add, area of trapezium BF, or we can say FBCH. So we will write trapezium FBCH plus area of triangle CHD we will have, right, plus triangle CHD. So these are the areas that we are going to add to get AB, C, D. Okay, E of the complete, if you have to get, then one more triangle is there, AED plus triangle AED. So what we have done, if we add this triangle and this trapezium and then this triangle, the lower one, that is AED, we are going to get, or ADE we call, so we are going to get the area, right? So first of all, let us find the area of AFB. Okay, half into AF is the base and BF is the perpendicular, that is of 2 centimeter, and AF is already given as 3. So 2 and 2 getting cancelled, we get the answer as 3 square centimeter. Now area of trapezium FBCH. So FH, why FH? Because it is just C, the distance between these two parallel lines. So this is the height. So FH is how much? 3 given here. Then BF and CH, these are the two perpendiculars, given the measurement, these are the two parallel lines. So area of trapezium we have learnt in the previous lesson that it is height into sum of parallel sides divided by 2. So we have added the sides. Now how to find out FH? From AH, if we subtract AF, we get FH. So FH is also how much? 3. Okay, FH is 3 then, because this total is 6. So we got this. So by solving it, what we will get, just to see, we will get 3 into 2 plus 3 is 5 upon 2. So we get 15 upon 2 square centimeter. Right, students? Now area of the triangle, this CHD, so base is 2, area base is 2, height is 3. So we will just write 2 into 3. So we'll get 3 square centimeter only. Clear? Then area of triangle ADE, half into AD. Can you just see how much is AD? AD is 8 and GE, that is given as 2.5. So 2 4s are 8. 2.5 into 4 is 10. So we get 10 square centimeter from here. So now we have to add them all to find the area. So just to see, area of the triangle, the first triangle, it is 3. Okay, area of trapezium is 15 upon 2. Just see carefully, 3 into the sum of parallel sides, that is 5 divided by 2, 15 upon 2, plus area of CHD is 3 plus area of triangle ADE is 10. So 10 plus 3 is 16. So we get 16 plus 13 upon 2. Taking the LCM as 2, we get 32 plus 13, that is 2 plus 3 is 5. 3 and 1 is 4, 45 upon 2. So 45 upon 2 is 2 2s are 4, 2 2s are 4, 22.5 square centimeter. This is the area of this polygon ABCDE. Right? So what we have done, we have divided it into parts of triangles and trapeziums, and then we have calculated the area. So in every question where some polygon would be given to us, we are going to try to convert them into parts like triangles, or we will divide it into parts like triangles, trapeziums, and then we are going to apply the formula of triangles and trapezium to find out the answers. Right? Okay, just see now. Here is one more question. Here MNOPQR, this is a hexagon given, this is a polygon, and MP is given. Just to see, the complete diagonal length is given as 9 centimeter. Okay, and MD is 7 centimeter. MD is 7. Okay, so just see, MD is 7 and MC is 6 centimeter. Okay, MC, you see, MC is up to here 6 centimeter, and then we have MB as 4 centimeter. MB, you see, MB is 4 centimeter and MA is 2 centimeter. Okay, and these are the perpendiculars and whose length are written in the figure. So how will we find the area of this? So we have 1, 2, 3, 4 triangles and we have 2 trapeziums, right? So first of all we will find area of triangle. We can write it as MAN. Area of triangle MAN is half into base. Base is what? MA. Is MA given? Yes, it is given as 2. So half into base into height, that is 2.5. 2 and 2 got cancelled. We get 2.5 square centimeter. Right. Now talk about PCO or OCP. Okay. Area of triangle PCO. Okay, that it will be half into base into height. So half into base is what? Base is CP, right? Can we find the length of CP? Just see, we have been given MC. MC is 6 centimeter and MP total is 9 centimeter. If out of that MC is 6, then what will be CP? 3. So half into base into height. So 3 3 is a 9, 9 upon 2 square centimeter, or we can just write 4.5 square centimeter is the area of this triangle. Okay, let us now talk about the triangle MBR. Okay, area of triangle MBR. It will be also half into base. Base is MB. MB is 4 given to us. Into height is 2.5. So 2 2s are 4. 2.5 into 2 becomes 5 square centimeter. Now we will find area of one more triangle is left. Triangle we have calculated for MBR. Now we will calculate for PDQ. PDQ half into base. Base is what? PD. Can we calculate PD? Just see, PC have been calculated by us, that is 3. Okay, now how to find out this? We have to write what? Half into base. Base is just see, I am writing here. Base is PD in this case and height is 2. Right, so 2 and 2 will get cancelled. PD will give the area of this triangle. So our purpose is to calculate PD. So just see here now. So we know that MD is 7 and MP is 9. From MP, if we subtract MD, MP is how much given? 9. MD is 7. So how much PD is left? PD is 2 only. Okay, so 2 square centimeter is the area of this triangle. Now all the triangles are completed. We are left with 2 trapeziums. So first of all, area of trapezium, the first one, ANOC. ANOC, that is height. What is the height? Here the height is AC. Can we find out AC? From MC, which is 6, if we subtract AM or MA, that is 2. So we are left with this as 4. So we will write height, that is 4, into upon 2 into the sum of parallel sides, that is 2.5 and 3. So 2.5 plus 3. 2 2s are 4. 2 into 2.5 plus 3 is 5.5. So we get 11 square centimeter as the area of this trapezium. Now one more area is left. Area of trapezium. The next is which trapezium? The lower one. What is the name given to this trapezium? As we can see, it is RBDQ. RBDQ. So how will we find the area? What is the height in this case? The height in this case is BD. From MD, that is 7 centimeter, if we subtract MB, right, 7 minus 4, what is BD then? BD is 3. So height is 3 upon 2 into the sum of parallel sides. So the parallel sides are 2.5 and 2. So 2.5 plus 2. So 3 upon 2 into 2.5 plus 2 is 4.5. Right. So just see, we will get 3 into 4.5 we will do first. 3 into 4.5, that gives us 3 5s are 15, 1, 3 4s are 12 and 1 13. So we get 13.5 upon 2. Okay. So 13.5 upon 2 that is equal to 2 6 are 12, 2 2s are 4, 2 5s are 10, 6.25 square centimeter. So we have got all the areas. Can we now add these to find out the area of this given polygon MNOPQR? Yes, definitely we can find out. So we are going to add at the end all the areas. Okay, so total area will be equal to, just see, 2.5 plus 4.5, it is 6.5. 6.5 plus 5, 11.5. 11.5 plus 2, 13.5. 13.5 plus 11. 13.5 plus 11. Can we add them? Yes. We get 5.5, 3 and 1 4, 1 and 1 2. 24.5 we get. In 24.5 we have to add 6.25. 24.5 we have to add 6.25. Just to see, if we add them, 24.5, 6.25, 5, 7, 6 and 4, 10 and 30. 30.75 square centimeter is the area. Is that clear? So we have calculated for all the triangles as well all the trapezium. So without using a formula, we don't have a formula for the polygon. So this concept can be applied to any sided polygons. Right, any n-sided polygon. It can be 5, it can be 6, it can be 7, 8 and so on. Right, so this is what we are also going to use in some of the questions. Let's go ahead. So here if you see, there is a question given. They are saying the area of trapezium shaped field is 480. So what we are given? Area of trapezium. So area of trapezium is equal to 480 square meter. What we know the formula of trapezium, we know that the formula, so we will apply that. Before that, what we are given? The parallel side, the distance between the parallel side, that means this is the height, right? And one of the parallel side is 20. So we know the formula is height into sum of parallel sides divided by 2, and that is equal to 480 as given in the question. So according to question we have written this. According to question, 480 is the area, and according to us this is the formula. Now the distance between the parallel sides is the height, so instead of h I am putting 15, and one of the parallel side is given as 20. So let it be A. We have to calculate, suppose B upon 2 equals 480. So 20 plus B can be written as 480 into 2 divided by 15. Shift this 15 to that side. It is in multiplication, so we'll go in division. And it is in division, so we'll go in multiplication with 480. Now, can we cancel this? Yes. 15 ones are 15. 15 threes are 45. We are left with 3. 15 twos are 30. So we are left with 20 plus B equals 32 into 2 is 64. Okay. So now we can say B is equal to 64 minus 20. So B is equal to 44 meters. So the second parallel line, the line that is parallel to A, which is 20 given, the second side is 44 meters. Clear? This is how we use the formula of trapezium and apply in the questions. Right? So should we move to the next question? Right? Okay. Here the area of rhombus is given. So if you recall, we have done the area of rhombus. What is the formula for area of rhombus, students? Area of rhombus is equal to half into the product of both the diagonals D1 and D2. Area of rhombus is given to us as 240 square centimeter. So half into one of the diagonal is 16. So we'll write 16 centimeter into D2. We can cancel it, 2 8s are. So we get 8 centimeter D2 into D2 is equal to 240 square centimeter. So what will be D2 equal to? 240 square centimeter divided by 8 centimeter. Centimeter and centimeter will get cut. 8 ones are 8 threes are 24 and 0. So the second diagonal is coming to be 30 centimeter. what is the measurement for second diagonal of this rhombus? It is 30 centimeter. So we were given the area and one of the diagonal. Using the formula that area of rhombus is half into the product of diagonals, we have calculated the second diagonal when we know the area and one of the diagonal. Okay, so let's move to the next question now. Here if you see, there is a regular hexagon given. Regular hexagon means, regular polygon means having all the sides and angles equal. So in this, all the sides are equal. Aman and Ridhima divided into two different ways. Okay, so this is Ridhima's method and this is Aman's method. So we are going to solve by both of them. So this is Ridhima's method and we have to find area of this hexagon using both the ways. So according to Ridhima's method, if we see that two triangles and one rectangle in the center is formed. So let us name it first, and the name is given to it as M N O P Q R. We are given this RP as 8 centimeter. Okay, we are given, so this will also be 8 centimeter. This is given as 5 centimeter, so this will also be 5 centimeter. Area of rectangle can be easily calculated. Now if we draw perpendiculars, right, to find out the height of these triangles. So if we observe, the base of both the triangles will remain as 8. Height, what is height going to be? Now this complete is 11. Out of it, if we cut, right, like this, so this is 5. The middle part is 5. What about the rest over parts? 3 and 3. It will be divided like this. So 3 above, right, and 3 below. And the middle part is, just see, from here to here if we have 11 and this much part is 5. Then 3 here and 3 here, because it's a regular hexagon, so equal partitions would be left over on the top and bottom. So we can find out area of triangle MNO, and then we have to find area of triangle PQR plus area of rectangle MRPO. So area of triangle MNO is half into base is 8 into height, that is 3, plus area of triangle PQR also half into base is 8 and height is 3, plus area of the rectangle, it is length into breadth. Length is 8 and breadth is 5, right? So if we add them, 2 4s are 8, 4 3s are 12, plus 2 4s are 8, 4 3s are 12, plus 8 5s are 40. So we get 24 plus 40, that is 64 square centimeter. Don't forget to put the limits at the end when you write the area. Right, so what is the answer? 64 square centimeter is the answer for this. Is that clear? Now we are going to follow Aman's method, okay, to find out the area. Here is Aman's method. Okay, so what we need to do in Aman's method is, it is given as 8, it is given as 11 and it is given as 5. So of this regular hexagon, how we can find out if the diagonal NQ, just to see this diagonal if we join. Okay, now it is divided into two trapezium, right? This is 11, this is 5 given, so this is also 5, this MR. So can we use the formula for finding out the area of trapezium, two trapeziums? So what about, suppose this is the height, yeah, right, this will be the height of trapezium. Also in this will be the height of trapezium, or this will be the height. So the complete is given as 8. So because this is a regular hexagon, it will be divided into 4 and 4. Okay, now we can find out area of the trapezium. So if first trapezium we find out, that will be half into, what is the height, we have 4, into the sum of parallel sides, that is 11 plus 5. So you see, half into 4 into 11 plus 5 is 16. So 2 1s are 2, 2 2s are 4, we get 32. Of the second one also, we have the same side 5 and 11, of the trapezium, and we have the height as 4. So 32 plus 32, because of the second one also it is going to be same. So 32 plus 32 is 64 square centimeter. So from both the methods we are going to get the area as 64 square centimeter. In Aman's method we have found out the area of the trapezium. It is MRQN, and plus area of the trapezium, the second one is OPQN. So these two we have calculated and added, and the area of these both are going to be same, because the parallel side in both the cases are 5 and 11, and the height is going to be 4. So I hope this clears the concept. So we can divide a figure. Every student will have different ways of dividing a figure or a polygon to find out the area, right? The answer is going to be same for all, right? Because it has a unique value of the area that it occupies. It can't be different from student to student. Okay.